Hello. So, welcome to the course on cloud computing. So far what we were discussing is about that how this cloud computing evolved, what are the different advantages and challenges in cloud computing, what are the different associated technology to this cloud computing aspects. So, core architecture and what are the different other type of technologies which came up with those things. So, as we have seen, it may not be a totally new technology or new innovations as such, but it is trying to look at all these innovations, all these new approaches and coming up with the things. Another new development what we will look today is a container technology, right. So, what we are finding one way as we have seen that there are challenges in infrastructure build up, there are challenges in platform builder, there are challenges in software builder. That is why we try to migrate from our in-house installation to some service providers installation. So, typically as we have discussed on XaaS type of services, infrastructure, platform and software, these are the different type of services. Another problem which is coming up nowadays is or rather with the development of software and other developments, like there is a redeployment or reconfiguration or recompilation of the software whenever we want to ship one package from one environment to other. This is one of the major motivation towards this. These days we are having devices which are pretty resourceful, say your mobile device or some notepad or laptop or even these days smart watches. So, all those things are resourceful and able to run different applications, right. So, one way is looking at that sort of things. Another aspects of it is we are having variety of applications development across the things, right. So, this type of portability of one application from one environment to another is becoming a major challenge. So, there where the container technology came into picture, where we will be able to bundle up the application along with its associated dependencies into a container and push it as a single container to the other type of environment, and if the container fits, your applications start working on that. So, cloud in such cases can be a platform to host this container. Though there are in some literature or in some forum people say this container technology is something a contender to the cloud, but what we see this is not exactly a contender to or a something which is fighting with cloud. Rather cloud can act as a platform to host this container, and basically cloud can enhance its capability by adopting this container technology. Right. One such container which has become a very popular is the Docker, a open source container which has become a Docker. So, what we will see a brief introduction to this Docker container, right. It will help us in understanding this how this portability of different systems and software will be there, and also help us in looking at this container technology with a background of cloud computing. So, if you look at the Docker, it is somewhere initial release were March 2013. So, it is a container management service, right. Main feature of Docker are develop, ship, run anywhere. So, this is this key words if you can see, like develop, ship it and run anywhere. So, irrespective of where it is, it should be able to run. This is basic philosophy of Docker, which tells everything, like you develop once and ship to any environment and run to this. It can be any your desktop environment, it can be a Android environment, it can be a iOS environment, it can be a say any cloud environment, it can be OpenStack, it can be Azure, it can be Bluemix or Amazon, anything, right. So, that is exactly the container things tries to say. So, the Docker aims at facilitating developer to easily develop applications, ship them into containers which can then be deployed anywhere, right. It has become the buzzword of our modern world development, especially in the face of agile based projects, right. So, this is the buzzword these days to look at this type of things. We will try to make a quick analogy of the things and try to understand what is there in this type of things. Now, if you look at how our computing paradigm developed, so it was somewhere a system, like it may be a somewhere something like a laptop or even desktop or some specialized board or chassis with blade servers and any type of things. Even if I can look at some devices like network devices, where we basically build some applications for them, right. Now, if I am running something on a particular laptop and then want to run it on a server thing, then in some cases in most of the cases I need to recompile the things, right. I need to align the things or redevelop, not that redevelop the whole thing, but I need to redevelop a major portion of the things or recompile the thing for the server. I want to do for another type of another type of system, I need to again redevelop the things. So, what is happening, that there is a lot of manpower uses into the things, whereas on the other side, so one side that there is a large dev means, or there is a every day we are coming, or means periodically we are coming with new systems and softwares and OS and type of things. On the other hand, we have several applications which are coming up on the other hand. Some may be static website, something like background worker like Python and so forth, user DB, analytics DB, QE, API endpoints, web front end, and endless things are being developed, right. Now, if you look at that, for everything, if you want to ship a application from one to another, and if you want to do this sort of recompilation or reconfiguring the things, it is a hell of a job, right. So, what we try to when we look at that interoperability or portability, what we try to do, we try to set up a matrix, like say static website, whether it will run on this particular device, whether it will run on this device, and so forth, right. It is a user DB and type of things, right. So, if I put tick on this matrix, then this is there. So, our major objective is there with minimal investment in terms of manpower, skill, infrastructure and software and so forth. I should be able to have all ticks on this matrix, like anything can run anywhere type of situations, right. So, that is a big challenge, this is a big challenge to adhere, but nevertheless the whole computing world wants to achieve this, right. This leads to commercialization of a product in a better way, marketability of a product in a better way, and rather in some cases, like if you look at sensor based technologies, if the sensor applications runs only on a particular type of smartphone and or a particular type of OS and it is not running to the other things, then your capability also decreases, right. I could have captured through different type of mobile devices, but that portability becomes a major challenge. So, these are some of the things which has driven that whether I can have some intermediate mechanisms which allows me to transfer this data. Now, if we try to look at some analogies, look at shipping. I want to ship some product from one to another. So, one side these products are there, like there can be variety of products, like it can be a box, it can be a car, it can be some barrel, it can be even a piano and drums and servers and etc. So, these are the things I want to ship from place A to place B, and it can be shipped in various form. It can be in somewhere some trucks and sort of things, somewhere can be dumped into a racks, some forklifter to lift on the thing, somewhere some locomotive or trains, being manufactured out of factory and shipped and through crane and put on the ship for shipping from across the continent, right. So, there are a variety of products and variety of techniques and technologies which are involved in shipping these products, right. Unless I standardize, like if you think that the type of mechanisms required for a server will differ from how you do for a piano or what you do for a car, right. So, unless I make a standardized way of doing this approach, doing this business, then things will not work, right. So, what they found out? They found out a concept for this sort of a docking station or this sort of a chamber, where if it fits in, it can be shipped. So, what we do, any product we put into this sort of a docking station, right, or this type of a box, and that this box has a standardized size, standardized mechanism of holding, and it can be either put on rack, put on forklifter, put on crane, put on ship, can be taken out from factory or inside the factory or put on the trucks and carried, right. These are very popular. Now, I made this shipping thing to any type of mechanism to transport by making a intermediate mechanism called shipping containers, right. Whether I can make this thing feasible for our applications, for our software applications. Now, this container is a standardized size, right. So, if somebody can hold the container, it can hold these products, right. So, what it does, the inside the container is more on the product which dictates, outside the container the infrastructure which dictates, right. This outside the environment of the container is more inclined towards this infrastructure by which it is shipped or where it is stored and type of things. Inside the container is the way where the product is stored, right. Like piano may have a different requirement of environment than car, than a server systems, right. So, this same type of conceptually, the same type of philosophy is being carried to this when we talk about container platform, when we talk about Docker, right. So, same thing what we say, it is a Docker service. We have different applications and there are different devices, and if I can dock it in somewhere other, right, which is standardized, and if these devices are able to handle this container or Docker container, then my application will run. So, what inside that container is there? Based on the applications, all these related libraries, binaries, dependencies, etc., are contained in this thing. Externally, which infrastructure it is running, that is important, right. So, this sort of philosophy helped in as we stating that you develop and ship to anywhere, right, develop, build, ship anywhere, right. So, this type of technology is becoming extremely popular and becoming a de facto standard for this, and what we feel that is necessary to discuss, because most of the cases what we are doing in a cloud, we are trying to run different applications within this cloud, right. Like if you look at, say, I want to run a particular banking application, or we talk about some special web service application. So, what it tries to do? It tries to build a particular container class in a sense, or a club of services which need to be shipped or needs to be done at different environment. Let it be Azure cloud, let it be OpenStack cloud, let it be any other sort of cloud like IBM Bluemix or Amazon or Google Cloud Platform, any type of platform. My basic requirement is there, I should not redevelop for every environment, right. And as well it should run if the resource permits on my smartphone or my desktop systems or server and so on and so forth. So, this sort of portability of the things this container brings into picture. So, if we look at again the basic features. So, Docker has the ability to reduce the size of development by providing a smaller footprint of the operating system via containers, right. So, in the container you have a smaller footprint of the OS. With containers it becomes easier for software teams such as development, QA teams, operations to work seamlessly across different across applications, right. So, they are maybe at different centers even for one organizations, and it can work seamlessly because finally it should fit into the container and being shipped to the other things, right. One can deploy Docker containers anywhere on any physical and virtual machines and even on cloud, right. So, it is a Docker containers can be deployed anywhere, practically anywhere, or any physical or virtual machines in VMs or physical servers and even on cloud. Since Docker containers are pretty lightweight, they are easily scalable, right. That is an important factor. So, this container, this Docker container is lightweight, and as it is lightweight, then scalability is much easier. If there is a heavyweight stuff, then there is resource requirement will be much higher, and anything portability becomes, or scalability or scaling up, or especially scaling up becomes extremely difficult. So, as this is lightweight, this is much easier. There are different variants, or what we say different flavors of things or components. So, Docker for Mac, it allows one to run Docker container on Mac OS. Docker on Linux, it allows one to run Docker container on Linux OS. Docker for Windows, Docker engine, right. It is used for building Docker images and creating Docker containers. Some sort of over the bare metal OS, you have the Docker engine, over these Docker containers are placed, right. Some sort of analogy with the hypervisors of a particular virtualization system. Docker Hub, this is a registry, is the important thing, registry which is used to host various Docker images, right. So, this Docker Hub you will find various Docker images. If you are a developer, you can basically submit into Docker Hub, which can be used by others to use it. Docker Compose, this is used to define application using multiple Docker containers, right. So, it is a composition sort of composition service which is used to define applications using multiple Docker containers. So, these are different components, there are various others, or the different flavors of these Docker or different components of these Docker things. So, if you look at the traditional virtualization, so we have that underlining server or bare metal or the backbone systems, physical systems. Over there is a host OS which basically provide the service to this server. Over that we have that hypervisor, right, or VMM or virtual machine monitor, and this helps us in generating different VMs, right. And every VMs can have their own guest OS, and over the guest OS different application runs. So, this is the basic philosophy of virtualization, already we have seen. So, the server is the physical server that is used to host multiple virtual machine. Host OS is the base machine such as Linux or Windows. Hypervisor is either some sort of a hypervisor, it can be VMware, Xen, KVM and type of things, or commercially VMware or Windows Hyper-V that is used to host virtual machines. One should then install multiple operating system as virtual machines on the top of the existing hypervisor as guest OS. So, what we do in case of a IaaS type of cloud, and then host your application on the top of each guest OS. So, this is the way normally a traditional virtualization work. A variant of this Docker architecture is that it has the server OS, guest OS, and then we have the Docker engine. So, over the Docker engine we can run different apps, right. So, it is going to be lightweight, and of course, you may not do very large applications, but nevertheless if your application is not so demanding, you can basically deploy out here. Server is a physical server that is used host multiple virtual machines. Host OS is the base machine such as Linux or Windows. Docker engine is used to run operating systems which is earlier used to be virtual machines at Docker containers, right. So, it is running operating systems which is earlier used as virtual machine as Docker containers, and then finally, all apps now run on the Docker containers, right. So, it has now Docker containers where these different apps run on this Docker container. So, what we see there is a, though the philosophically maybe same sort of aspects is there, but there is some difference with this traditional virtualization. So, just to recap that containers are abstraction at the app layer that packages code and dependencies together, right. So, it is a, what is this container including Docker container? It is an abstraction at the app layer, that application layer that packages or bundle code and dependency together. So, it is together bundle. Multiple container can run on the same machine and share the OS kernel, and other containers each running on isolated processes in the user space, right. So, that is also possible. Container takes up less space than virtual machines. Container images typically tens of MBs in size and start almost instantaneously, as that is exactly what we are discussing. It is a low weight, and we can much less resource hungry than virtual machines, and it can start instantaneously, it is as it is a low weight. So, there are other few concepts which are comes back to back. One is that image. So, we are talking about images and type of things. So, an image in this context is a lightweight standalone executable package that includes everything needed to run a piece of software, including code, runtime, libraries, environment, variables, config files, etc. So, it is important, right. So, it is a lightweight standalone executable package that includes everything needed to run that particular software package or software, including code, runtime, libraries, environment, variables, configuration files, everything. A container is a runtime instance of an image that the image what the image becomes in memory when actually is executed, right. So, what is there? So, I have a bundle things, once it start running it is a instantiation of this image, that is exactly the container. It runs completely isolated from host environment, by default only accessing the host file and ports if configured to do so, right. So, it is independent of the host environment. So, other things, the container runs apps natively on the host machine's kernel, right. They have better performance characteristics than virtual machine that only get virtual access to the host resources through a hypervisor. So, it runs directly on the host machine's kernel. Containers can get native access, each one running in a discrete process, taking no more memory than any other executable. So, it is not only lightweight, it has performance wise also instantaneous. So, if you look at containers and virtual machines, so if you look at repeat that thing, so we have the underlying infrastructure of the server base, host OS, Docker, and then we have that containers, right. It has applications with other dependencies, right. Whereas, in case of a hypervisor or a virtual machine, over the hypervisor we have guest OS and rest of the things, right. So, that is the difference. So, virtual machine run guest operating system OS layer in each box, resource intensive. So, as it is requires more resources, resulting disk image and application state in a entangled with the OS settings, right. System installed, dependencies with security paths and so on and so forth, whereas container can share a single kernel and only information that needs to be in a container image is the executable and its package dependencies, right. So, what are the different other package dependencies which never need to be installed on the host OS, because it is bundled together. These processes run like native processes and can be managed individually every container. Because they contain their dependency, there is no configuration entanglement, and so containerized applications runs anywhere. So, that means I do not have any so to say any binding with this host machine, right. So, that means I isolate this my container based package with the host. So, it increases the portability and can be run any other system. So, same thing. So, if there is a running on a VM, then we have every app, every copy of an app, every slight modification requires some new virtualized environment, whereas in this case slight modification can be done, allows us only to save the difference between the container A and container A dash, and that can be done at the at that container level. So, overall working, as we have the Docker, as we have seen, this is the Docker engine is there. So, from the source code repository we build over this Docker engine, it is a container, a particular container class container A, push it to this container image registry, which is which can be searched by the users or the consumer. This container finally is basically this Docker is some sort of a client server mode operation. So, it search and then pull these things and run on this particular different instantiation of the different container classes. So, if we try to look at altogether like how it can run on the cloud. So, we have infrastructure hypervisor over that gateway, we can have a Docker services, right. In this case we have two different container, here only one, and so on and so forth. So, the cloud can host or can become a platform for running this container type of services. So, that is on some VMs, that is in a IaaS type of cloud, we can run this sort of services. So, there are needs are enormous, needs, requirement, applicability is enormous, like application level virtualization is possible. A single host can run several special application for utilization of resources. As we have seen when we discussed about spatial cloud, there are several special applications, and now we can have a single host which can run several special applications. Build once, deploy anywhere, run anywhere type of things, philosophy. So, once I develop and build it, and then I deploy anywhere, run anywhere. Better collaboration between development of applications. So, I can have better collaborative applications into the thing into place. There are few terminologies, some of them already have seen. So, like images, list of all local images, run, create a container from an image and execute a command in it, tag an image, pull, download an image from a repository, RMI, delete a locate image. So, this is also remove intermediate images if no longer is used, so that resources can be released. There are some terminology which are more more associated with Docker container, like PS list all running containers, PS minus A list all containers including the stopped one, top display processes on the container, start, stop, pause, RM, delete a container, commit, create an image of the container. What you may notice that these are the most of the many of them things are some sort of Linux commands, right. Already we are used to it. So, in these cases also for container we can use those commands. Those who are interested, you can basically hook into docker.com and see that how the coding can be done and how a container can be built using a Docker engine. So, this is freely downloadable and you can work and you can run that things on your desktop or server or even on your Android devices, make a particular application and run on different devices. So, there are some few more things. One is that Docker file, create an image automatically using a build script called Docker file, can be versioned in a version control system like Git or SVN along with other dependency. Docker Hub can automatically build images based on Docker files on GitHub, right. So, these are things are possible. And Docker Hub, where the public repository of Docker images are there, like hub.docker.com, there is a good resourceful area for these Docker images, and automated has been automatically built on Docker file. Source for build is available on the GitHub. So, finally, if we look at the different viewpoint or different uses of this Docker, is a worldwide claim to be leading software container platform being used at various levels, various in different environment and became very popular. So, developers use Docker to eliminate work on my machine problem, right. So, there is dependency on the things. When collaboration on code and co-workers, collaboration on code with co-workers are much needed. Operators use Docker to run and manage apps side by side in isolated container to get better compute density. That is the viewpoint or the usage of the operators. Enterprise uses Docker to build agile software delivery pipelines to ship new features faster, more securely, with confident for both Linux, Windows servers, Linux on mainframe apps and so on and so forth, right. So, there are different applicability of the Docker, and this service is becoming pretty popular, and those who are interested in this particular Docker technology, you may go through that docker.com, and there are several other sources where you can see that how this compilation can be done and can have your own Docker images and run out on different platform and see the things, right. So, as far as the cloud computing paradigm is concerned, it acts as a platform and helps in application portability across cloud, making cloud more useful, more acceptable at different environment. Thank you.